So the second part of 3.1 is talking about the letter E and some formulas that use the letter E. But first, the letter E is actually a substitution for what's called Euler's number, and it's approximately 2.71828 and so on. And it is an irrational number, so that means it's repeating forever. You can approximate E as this formula right here. Okay, 1 plus 1 over x raised to the x power. As you substitute in larger and larger values for x, you're going to get a more accurate representation of the letter E. We call the letter E the natural number, the natural base. So whenever you see something to talk about the natural number, just know that it is E. When we're talking about the function e to the x, it's important to note that x is still the variable and e is just a number or a constant like pi. Instead of writing out 3.14 and all that stuff, we just substitute it as pi. Now, since this is another exponential function, it has all the same characteristics as the ones we talked about yesterday. The only difference is now that that other point, we want to try to make the exponent of that other point equal to 1. So that way we have 1 comma 2.7 on the graph. Like I said, sometimes we won't be able to do that, but that's just what we want to try to do to make graphing a little bit easier. So we won't be able to, graph these completely without a calculator. We're going to have to maybe use that for the 2.7 multiplied by a number or adding or subtracting to it. So we have 0, 1, and 2.7 is close to 3. So our graph would look like this and have a horizontal asymptote at y equals 0. Right, so let's go and graph this function here, 3 plus e to the x plus 2 power. So just like yesterday, our horizontal asymptote is y equals the number being added, so y equals 3. So 1, 2, 3. We're going to substitute in 0 for x. So f of 0 equals e to the 0 plus 2. So we have that 3 in front, but we can add 3 at the end if it'll make it a little bit easier. Then we get e squared plus 3. Well, e squared, if we type that in the calculator and we add 3 to that, we get 10.04. So we can show that, to get e in the calculator, you press second and the ln button. That's e raised to the second power plus 3. We get 10.4. So we get 0, 10.4, which is going to be off our graph a little bit. 1, 2, 3, 4, 5, 6, 7, 8, 9. We can estimate it there. Now, for our other point, we don't want to pick larger values of x. We want to pick smaller values of x so that way our point is on the graph. We want to try to make that equal to 1 or 0 if we can. Well, if we substitute -2 for x, so for this other point, if we substitute -2 for x, that will make the exponent 0. So then we get 3 plus e to the 0. Well, anything to the 0 power is 1. So this is going to equal 3 plus 1, which is 4. So we have -2, 4 as a point on the graph. And now we can sketch what this, whoops, I crossed the asymptote. We know we can't do that. Sketch our graph. Domain is still negative infinity, comma infinity. And then our range is 3, positive 3, comma infinity. Now this one, we have that negative in the exponent, but changing that to a positive is probably going to make things a little bit more confusing, because then we're going to have 1 over e to some power, and that just makes things a bit more tricky to deal with. So we're going to leave that for now. So our horizontal asymptote, y equals, we're not adding or subtracting anything, so it's y equals 0. We don't have a plus or minus anywhere. Then our y-intercept. Our y-intercept is going to be 2 times e to the negative 0.5 times 0. Well, now that whole exponent becomes 0. So f of 0 is going to be 2 times e to the 0 power, which is the same thing as 2 times 1, because e to the 0 power, that 0 power only applies to e. So now 0, comma 2 is our y-intercept. And now we need to figure out another number to use to substitute in for x that gives us a nice number. Now we can't plug in 0 for x to try to make this exponent equal 0, because then we would get the y-intercept again. So let's try to make that 1. Well, what number times negative 0.5 will give us positive 1? That'll be negative 2. So our other point, we're going to substitute in negative 2, because that's going to give us an exponent of 1. So then we have f of negative 2 equals 2 times e to the positive 1 power. Well, e is 2.7, and when we multiply that by 2 times 2.7, we get 5.4. So our point is negative 2, comma 5.4. So that will make our graph behave this way. Our domain, again, is negative infinity, comma infinity, and our range is 0, comma infinity. So to be able to graph these functions, you really need to be able to use your properties of exponents, knowing that anything to the 0 power is 1, and that if we raise anything to the first power, we just get that value back. Now we're going to talk about using exponential functions in calculating the growth of money. So if we compound our interest, we have a formula here, a equals p and then parentheses 1 plus r over n raised to the nt, where over here the a value is what we end up with, p is the original amount called the principal, r is the rate as a decimal, what percentage, and then n is the number of compound periods in 1 year, and t is the number of years. Now, based on what the problem says, how often we're compounded, annually, semi-annually, monthly, quarterly, or daily, this is the value of n you would use based on the wording in this formula. Now, if you hear or read a problem that says compounded continuously, then you use this formula, p times e raised to the rt power, where the only difference is you no longer have an n value. And again, you only use this formula when compounding continuously. So in example 4, suppose we're investing $1,000 at 8% over 10 years. How much will the investment be worth if the interest is compounded monthly or compounded continuously? So for the problem, our principal is 1,000. The R is 8%, which is 0.08, and T is 10. So we're going to do this monthly and continuously. So for monthly, our n value is going to be 12 because there are 12 months in a year. Continuously, we don't have an n value. So A is equal to 1,000 times 1 plus our value 0.08 over n, which is 12, raised to the n times t power. So we're going to type that all into our calculator here. So 1,000 times 1 plus, and then we can do 0.08 divided by 12, close the parentheses, raised to the 12 times 10 power. Now, if you want to just type in 120, that's fine. I'm just showing you how you would type it into your calculator, because what if it was, 8 years and you were compounding weekly? Right? That would be hard to maybe multiply in your head. So our A value was $2,219.64. So 2,219.64. Now for continuously, our formula is A equals P times E to the RT power. Much easier to substitute in. So we'll go over here and we'll do 1,000. And again, do second ln. That gives me E raised to the 0.08 times, we know T is 10. So we get $2,225.54. So it is better to compound continuously if you have that option. So thanks for watching the video. Make sure to like it and subscribe.